Hi guys, welcome back to another video. As some of you may be aware, I've done a YouTube short on a mini portable USB-C charger for the Yaesu FT-4V that I own. The original idea came from Ian, Mike 0 Juliet India Alpha, who really liked his Yaesu FT-65, but was always frustrated that the only way to charge it is with the bulky desktop charging cradle. He spent quite a while searching online to see if there was any commercially made units or if someone had come up with a more portable solution. There was plenty of discussions about it, but he couldn't find anything that really matched what he wanted, so decided to build his own with a bit of help from ChatGPT, Tinkercad and his new 3D printer. He designed this compact USB-C magnetic charger for his FT-65. Before we go into details of the build, I just wanted to talk about some of the specifications that I do know and my experience so far. So the original Yaesu cradle, this outputs 8.4 volts at 800 milliamps using the mains adapter. That will charge the FT-4V's battery in approximately 3 hours and 10 minutes from flat. Ian's charger, this puts out 8.4 volts at 1 amp and takes around 3 hours to charge a flat battery. The modules used inside the USB-C charger is 200 milliamps higher, and also with the Yaesu charger, as you can see, has got 3 pins, and on the back of the radio it's got 3 pins. So having a little research online, the Yaesu's battery and charger, you've got a plus, a T and a minus. The T stands for temperature, and the T terminal is used with a built-in temperature sensor, a thermistor that monitors how hot the battery gets whilst charging. The charger reads the temperature data to prevent the battery from overheating. If the cells get too hot, that T pin signals the charger to throttle down or completely halt the charging process to protect the battery pack and prevent damage. Whereas the USB portable travel charger doesn't have this temperature sensor. Whilst doing some tests on each charger, I used a handheld temperature sensor and took some readings at different intervals over the charging periods. While this isn't any lab conditions or full testing, it gives some ideas of the temperatures while the battery is being charged, and obviously will change over time of the battery's life, so it's something to bear in mind. I'll put up on the screen now a little table that I've done, and looking at the Yaesu's charger, you'll see the differences in time and temperature compared to the USB-C charger. So I'll leave that up on the screen, you can pause it. What I will say is I won't recommend the portable USB-C charger as a complete replacement for the original Yaesu charger, and suggest it used as more of a travel charger when space is of a bit of a premium. Again, it's down to the user to construct, test, make sure they're happy with it and acknowledge the limitations, and never leave the charger unattended. Ian's charger was designed around his FT-65. He doesn't use the belt clip, so keeping the charger in place, he used metal discs, as you can see here, and there's 2 small magnets on the back of the charger for alignment and retention. So there's the metal discs, and you've got the magnets there which have got some grooves in the 3D print. And his idea was, without the belt clip, you'd stick those on because they've got adhesive backs that you just pull off there. You'd set it all up, and then the charger with the magnets would sit on top, and that's how you charge the radio. Quite a neat idea, liked it quite a bit, but I like to use the belt clip with my FT-4V because I've got a mount in the car, and sometimes I put it on my rucksack. So I wanted to slightly tweak his design of the case and just change it so the USB port comes out at the side. So I'll just put the battery, the belt clip back on the battery, and I'll show you. So I've got the belt clip on the back of the FT-4V, and going with the charger, that's Ian's one. If I was to put it on, obviously there's no place for the USB cable. Don't even think you could probably get an adapter, an angle adapter in there. So like I say, I've just slightly modified the actual case, made my own sort of design on it. I like what Ian's done. You can use this on the FT-25, 65 and obviously on the 4, where I've done this one here, and that tab here will just go into a small little hole. You can just see it in between the belt clip and the housing of the radio, and slides up into there. That gives it a bit of top security, stop it wobbling. The belt clip will gently pin it down, but there is a bit of slight movement when it's up and down, but that's a bit of force. I've got to give that a bit of pull to make that move. So it seems to be quite steady there, not going to move around. The pins attached to the terminals are keeping the bottom in place as well. So that's the only difference. I haven't tried this on an FT-65 or an FT-25 because I don't own one. It probably, because they're a little bit larger, I don't think it'd make the full connection. So I'd have to get one of those radios and just have a look at the case. But maybe you could try and build your own if you wanted something similar. So let's get on with the build. So I'm just going to pop the required parts up on the screen for the USB-C charger. You'll obviously have to decide if you're going to print both of the cases off or just one of them. Remember, Ian designed his around the FT-65 without a belt clip, but should work with the FT-25, FT-4V and X, obviously without that belt clip. I just changed the design slightly for the FT-4V and X with a belt clip. Then we'll need a USB-C trigger module, which is purple, a TP5100 2S lithium ion charger module, 2 pogo pins, and if you're going to go for Ian's case, it's 2 magnets, 2 adhesive discs for that case. So that's when you print off, if you're going to print off my version, you'll just have 2 parts to the 3D printed case. With Ian's, you've got this spacer module that sits on the back. It just gives you room for the magnets and the discs, and then you've got the top case that will go on as well. So I'll just push this to the side. As I've already done one for the FT4, I'm going to use Ian's case this time. There's the discs and the magnets, so I'll just move those to the side because we don't need those at the moment. What I will show you, very tiny, is the pogo pins. So that's what you got there, and what they've got is a bit of a spring action in them as well. So that's the pogo pins. Be careful because you will lose them pretty easily. They will spring across everywhere. This is the TP5100 lithium ion charging module. We're going to start off with the trigger module first, the purple board. So there is a few different sizes. I'll put a link in the description, but please bear in mind sellers will change items around, so these will fit into the cases, this particular one, but we have seen that other ones are maybe a little bit slightly wider, but it should be okay as long as you find a purple one. So quickly going back to that list as well, you'll need a one of these PD mains adapters. This one's from Anchor. If you just pull this out here, an iPhone one or a Samsung or a Nokia one won't do because they only produce 5 volts. We need a slightly bit more voltage than that, and with these ones here, because of the trigger board module, it can tell it to give us a different voltages, and if we look on the back, they're the voltage range that we can get hopefully from something like this, but we only need 9 volts. So as you can see that table, so we've got 20, 15, 12, 9 and 5 across the left hand side, and across the bottom is S1, S2, S3. So we want 9 volts, we want on, off and off. Looking at the board, we're looking at these dip switches here, which are very tiny. Be careful you don't get too confused. if you've used dip switches before, because sometimes on other dip switches it will say on, but I think that's some sort of brand name. We're looking at the board itself, so we've got off and on. So you just want to make sure that you get something in there that can just push it down, up and up. Your board might vary, so please always check the back of the module to see what their table is saying. There may be some slight change in a future board or anything else like that, and it might be a different configuration, so always check your module on the back. So we want 9 volts, and to confirm that, we'll take the charger with a USB lead. Just unravel this for a second. Just going to plug it in. And you should see a red light pop up on the module. If I can get that in. Right, there you go. So there's the red LED. And what I suggest is take a multimeter and confirm that you've got 9 volts. So there's the multimeter. I'm just going to take the module, and we're going to use the pins at the side. So you've got VCC and ground down there. So I'll just go for, let's try and get it all in shot for you. So you've got the VCC and then the ground, and we've got 9.11 volts. So that's that module set up. We don't need to do anything else with this board. Keep your multimeter handy, so just take that out now. So that's that set up, that's all done. Move this off to the side. Now, taking this TP5100 module, we need to carry out a solder jumper to the set pin. So that set pin is down there. With the set pin, if you leave it open unsoldered, it's for a single cell 4.2 volts, but if we bridge it, that will allow for 8.4 volts. So we need to put a little small solder blob there. So I've got my soldering iron ready. Make a bit of room, and then we just need to do a little small blob of solder across there. So there you go, there's a blob of solder. And then with this module as well is a setting for the current charge on the board. There are 2 SMD resistors, and they're both labelled R100. You can just about see that there, R100. That meaning they're 0.1 ohm each. The default setup for both of them in situ is a 2 amp charge rate, which is what we don't want. That's too high. So there's a method of basically desoldering one of them, one of the R100 resistors, and that leaves a single 0.1 ohm resistor in place, and that's halving the current down to 1 amp. There are other options I haven't explored. Searching online, you could carry out, but it would need testing by either removing both of them and then placing a R20 SMD, which is a 0.12 ohm. That would give you 830 milliamp charge rate, which is closer to Yaesu's charger. But buying just a single one of those, you're going to probably struggle. You'll have to buy like maybe a reel. And when I did look into it, the postage was more than the actual components, so I didn't bother going down this route. There is a 500 milliamp charge rate, so if you remove both of these and then solder them, like stack them on top of each other on one side, so take that one off and put it on top, that will give you a 500 milliamp charge rate. but again, it's something that I've not tried or done. So I've only done the removing one of them to give me 1 amp. So it's something that you need to investigate. You'll obviously, if you do that, either replacing the SMD for an R20 or putting this one on top of the other, you'll have to do some thorough testing, as this has not been done by myself or Ian. Just want to have a quick look at what one I removed initially. So it's quite, if I take my one here, as you can see, I moved the resistor closer to the edge of the board. It's quite a fiddly job. I'm going to try and do it on camera. Make sure you've got a fairly clean tip, and we're just going to try and just move it away. I'm going to try and keep it because I might try stacking them. So as you can see, it's removed one side, it's just pulled away. So I'm going to try and keep that somewhere safe. So that's the 2 mods that you need to do to this board. So we've got the set jumper there and removing that resistor. Quickly just tin across here. And same with the other module. So I'm just going to take my wire, I'm going to solder onto here. I've gone across the 2 pads. And I should do the same for the other side. I'm just going to cut a little bit longer. Get a bit more solder on there. Probably should have tinned the wire before I started, but just make sure they're a little bit straight, because they're going to obviously have to go between each module and be easier to line up. Right, so that's that. So we can place it into there, and as you can see, they'll just go through those little slight gaps in the board. Move out the way, and we can place that module down. You just want to get a rough idea of lining them up, and then you can snip the excess. Just going to solder that now. Just move this one over. So I'm just trying to do this with the camera in the way as well. Obviously be careful you don't heat it up too much, melting the case, 3D printed case. And there you go, so that's those 2 done. What we need to do next is take your pogo pins and I would suggest, obviously, you've got that roughly in place now. I wouldn't solder when the pogo pins are in place, because obviously that will heat up the 3D case and it will just melt. So I would tin the top of the pogo pins and then attach the wire on, leaving yourself with a bit of excess, and then you can go to the board. So I would just tin these here. And then I'm going to just do it off camera because I just want to get my vice and hold it in there. But I'll just tin both of these pogo pins and then put some wire on it. So bear with me a second. So as mentioned, here's the pogo pin. Then I put a bit of wire attached to it. And what you'll do is you'll basically place that in there. Get a rough measurement. I'll try and do it on camera if I can. Get it poked into there. You might need to give it a little push down just to seat it. There you go, so that will come through there. And then roughly take enough wire, snip it, and then I'd remove the whole lot before trying to solder it on, because that short length, and I'll show you in a minute reason why. I can print off another case because I've got a 3D printer, but such a short length, the wire will heat up the pin, as you will see from here. I just wanted to experiment just to see if I could do it in place, but that's what you'll end up with if you try and heat it up in place. So I would suggest cut the length that you need roughly to there. Obviously it doesn't matter if it bends around a little bit if you've got too much. So go from here, I want to take that much, and then I would just literally take out the whole boards, whatever way you find it easier to get it out. So I'll get the pin out, that will come out, and then solder that onto there, not in the case. I just wanted to try it just to see, but I should have known it was a little bit too short of a length. Right, you've got your pogo pins now soldered onto the board, and this is what it should look like. And just to confirm, you've set the dip switches to right sequence. You've also soldered that jumper link there, and you've removed one of the resistors. Before we go ahead and try it on the radio or the battery, we just need to test to make sure we've got the right voltage on the end of here. As you saw earlier, I did try and solder the pogo pin in place, and you can see the difference. So it slightly melted it. I've now printed off a new case. So this one's not melted. You either can put the unit into the case and do a test, but while I've got it out for the moment, let's plug it in first. Just set it here. You'll have a red LED and then this blue LED. When it's charging the battery from flat or just a normal charge, this will go red, and then once it's done, it will go back blue, turn to blue again. Just going to take my multimeter, use this as a bit of a stand, and let's just check to make sure we've got approximately or around about 8.4. So I'll put tab on there, and we're going to go on there. Will fluctuate a little bit, but as long as you've got approximately 8.4 or roundabouts, that will be it. So now I'm just going to put this into the case and we'll give it a test. What you can also do, once you put it into the case and the pins come through, we'll just hold that onto there. I'd put a little bit of glue behind your magnet and then slot it in, and then do the other one as well. And just where the pins come through, that'll hold this spacer bar in and it'll keep it where it needs to be. So I'm just going to install this and then we'll come back and try it out on the radio. And also probably with the case, start off at this end, push it in there first, and then adjust the pins, and using a tool with a flat end, just push the actual pogo pins down. So I'll just do this off camera. So I've got it into the enclosure now, and like I say, I just used the tweezers to line them up, and then I used this flat end to push them down, and then they poke through. Like I say, with the magnets, this will slot onto here, so find the two holes, line them up, and then you'll see those poke through, and that's where you could then, so that spacing piece there will keep it in place, the pins will hold it there, and then you can just add a bit of glue underneath, put the magnet on, and again put the magnet on there. Right, now that you've got it in your case and the magnets have been stuck on by glue, I've already done the metal discs. I used this spacer unit just to line it up roughly, and then it was put down, and then I've pushed them down. There is a bit of, I've used these discs before, so they're not sticking that great. Remember with the case, also you want the larger lip, or this tab, over the pins, and the shorter side goes over the USB port. I'm going to do this with the lid off at the moment, so you can just see, and I haven't got the spacer on there as well. So red LED, blue one. I would recommend when you come to do this, put it onto the battery first before plugging in this, just in case you cross over the terminals or anything like that. I'm just going to quickly just show you. So when it goes on, you'll get a red LED. So that blue one will change to red. That's showing you it's charging. And once it's charged, if I lift it off a little bit, it'll go blue. So that's how you'll know. So that's that complete. So then you can go ahead, put on your lid there, push that down, and then take the spacer, and that then allows it all to sit on there. And there's your travel charger. Hopefully you found the video useful, and especially if you're going to go and build one. If you like the design, please go to the Northumbria Amateur Radio Club's website. I'll link it in the description below. They've got a buy me a coffee. There's a projects page across the top tab, and when you go into some of their projects, down the bottom there's buy me a coffee. If you find it useful, just buy them a coffee, because Ian's part of the Northumbria Amateur Radio Club, and it was one of his ideas. He's got a few other projects on there as well. So you'll find a portable mask kit, a link dipole, there's details to a flower pot, there's also like a 3D printed part for the flower pot to help it connect onto like a roach pole or something like that. So there's a few bits and pieces. The money goes towards the club. It goes to help maintaining the website and any future projects of like buying bits and pieces to test and they're looking to add more projects onto their website. So guys, there you go. That is the portable USB-C travel charger for the Yaesu FT-25, 65 and FT-4V. Thanks for watching. 7-3.